I will talk about encoder in the context of digital electronics. I will talk about simple encoder, which is commonly called just as an encoder. So encoder is a device that will have few input lines and then some output lines that will display the binary number of the input line that one is high. Now among these input lines only one will be high at a time, which is also when in a binary stream there is only uh, a single bit is high. It's called one hot. It's an expression, but anyway, the inputs will have only one high or one active, rather it could be low as well, but let's say it's high. So only one high, and the output will say which input is high. So here I'm 3 4 5 6 7 1 2 3 4 5 6 7 8. So let's say 8 input lines, and output there are 3 bits. Now if this one is I0 or this one is I7, so if all these are 0 except I4, that one is 1, that means that the fifth line is 1. So the output will display 101. In binary it will say that the fifth line is high. Similarly, if I7 is high and everything else is 0, the binary output would be 111. So this is how the encoder works. So for an encoder, the output has to be, for 2 to the power n input lines, there will be n bits. So basically if we have 4 input lines, the output will be 2 square, so output will be 2 bits. Similarly, if we have like 8 lines, 8 line is 2 to the power 3, so there will be 3 output bits. Similarly, even if we have 10 lines, then we will need at least 2 to the power 4 will give us 16, 2 to the power 3 gives us 8. So it is more than 8, so we will need 4, since 2 to the power 4, not all of the lines will be used, but we will still need 4 outputs. So I can write the truth table for a 4 to, it's called 4 to 2 by encoder, or 8 by 3 encoder, 16 by 4 encoder, like so on. So that means this is the number of input lines, this is the number of output bits. So if I have a 4 to 2, so that is I3, I2, sorry, I3, I2, I1, I0. So this one is 1 and then I0, and then output is, let's say, x1 and x0. So when this one is 1, we can have just these 4 conditions. Only one will be 1 at a time for the simple encoder, and then we can have this one. So the first one means the 0, the 0 line, 0 designated line is 1, so it will be 0 0 here. This one means, the second one means the 1, it is 1, so 0 1. Third one means, which is 2, so 1 0, and fourth one is 1 1, because it's actually 3, I3, so we can say the third line, third actually fourth, but since we start with 0, that's the 3. So this is how. And if I write the binary expression, sorry, boolean expression for this one, how the gate can be formed. So here we see that these two, for x, this is 1 for I3, so x1 is I3 or I2, these two are 1, this one and this one. Similarly for x0, this is x0, sorry, x0 will be this one and this one. So here I3 is 1, or this one is I1 is 1, so like that. So our output will be, the gate arrangement will be like that. So there is another one, so I3 and I2, and then there is I1 and there is I0. So this is x1, and I1 will be there and I3 will be there. this will be x0. So that is x1 and x0, I3 or I1. So I3 or I1 is giving is x0. So this is the encoder for 4 by 1 4 by 2 encoder. There are ICs as well, which in an IC it will be like this. So the block diagram, if we say, it's like that. So that's I3, I2, I1, I0. And similarly we can have actually 8 by 3, 16 by 4 and so on, and then we will see that BCD to decimal to BCD encoder, which I will do later on. Probably I will do an 8 by 3 priority encoder, simple encoder. There are priority encoders as well, where multiple lines can be one. I will talk about that later.